Hello, everyone. Welcome back to College Algebra. This is a continuation of Section 2, Operations on Real Numbers. This is Part 2 of Section 2, Multiplication and Division of Real Numbers. I think this will be a really quick and simple lesson. So with this lesson, just like how we did with addition and subtraction, we're gonna pull a name for the answers of multiplication and division problems, and then we're going to talk about how these operations are done with like signs and different signs. Very quick, very easy. So, with multiplication, we have the product as the answer to a multiplication problem. The product. The product is the answer to 2 times 2 is 4. 4 is your product. So say we have 5 times 3. The answer to 5 times 3, or the product of 5 times 3, is 15. Now, in algebra and forward past algebra, you will almost never see this X symbol to mean times. You will never see it. What you will see is two other ways of writing it. You will either see 5.3 equals 15, or, now that's a raised dot, not to be confused with 5.3, which is a decimal number, something completely different. So this is not multiplication. This is. Make sure your dot is in the middle between the two numbers. So it could be either written with the raised dot, or you could have each individual number in parentheses. And that's a way of writing a multiplication problem. You will have 5 times 3 equals 15. So both these answers right here, both of these, the same thing, 5 times 3, they have the same sign, a positive sign. They're both positive. So what if we have two negative numbers? Let's scroll down a little. Let's scroll down a little bit. Use another marker. Let's go to yellow. I like yellow. So say we have -6 times -4. -6 times -4. When you have two negatives being multiplied together, you end up with a positive number. Negative times a negative is a positive. So -6 times -4 would equal 24. So it won't be -24. It will be positive 24. So what if the two numbers have different signs? Say we have, let's pull another marker. Let's go to purple this time. Say we have 2 times -7. When you have two different negative numbers, it doesn't matter which number is bigger, which number has this negative or positive sign. When you multiply two numbers, and one of those numbers, when you multiply any group of numbers, and one of those numbers has a negative sign, you will end up with a negative number. 2 times -7 will equal -14. So let's test that. Let's see what happens. Say we have 2 times 3 times -5. What happens? Let's see. We have 2 times 3 equals 6. So we have 6 times -5. Now we have 6 times, I wrote 15. Why did I write 15? Okay, sure. Now we have 6 times -5. That threw me off. Will equal -30. So, what happens if we do it the other way? So we have 2 times, what is 3 times -5? 3 times -5 will be -15. And 2 times -15 will be -30. Same answer, right? What if we have a multiplication problem with two negative numbers, but 3 or more numbers being multiplied together. Let's pull out orange. Let's say we have -1 times 4 times -3. Now, no matter what happens, if you have two negative numbers, it doesn't matter how many numbers are being multiplied together. If two of those numbers are negative, you will end up with a positive number. So let's find out. -1 times 4 is equal to -4. -4 times -3 is equal to +12. Let's do it another way. Let's say we multiply, we have -1, and what is 4 times -3? That will give us -12. -12 times -1 equals +12. What if we did negative numbers first? We have -1 times -3 equals +3 times 4 equals 12. It doesn't matter the order. When you're just strictly multiplying, if there are two numbers in the expression, it doesn't matter if you're multiplying 15 different numbers together, you will end up with a positive number. Do you see a pattern? When you have one negative number, you will always end up with a negative number in your product. When you have two negative numbers in your answer question or the expression, you will end up with a positive number in your product. If you have three negative numbers in your expression, you will have a negative number. If you have four negative numbers in your expression, you will have a product with a positive number. This is what's known as odd and even equations or expressions in algebra, and we'll get into that in another day when we have more appliances that we can, more things that we can apply these things to. Now, just like with addition, multiplication has an inverse property. Let's use the equation 12 equals 3 times 4. 12 equals 3 times 4. That's one of the expressions we used not too long ago. Multiplication has a property inverse, and we'll do properties coming up in another lesson, but this is the inverse that helps us understand multiplication a little better. We could write A is equal to B times C. Now, this is only true if B is equal to A divided by C. What did I just do? If you remember your multiplication from arithmetic, any number divided by that same number equals 1. And when 1 is in front of another number or being multiplied to another number, you don't have to write it. So let me show you what I did. We had 12 equals 3 times 4. If we divide both sides of this equation by 4, what do we get? On this side, we get 3 times 1 because 4 divided by 4 is 1. So the 4's cancel out is what we're often told in grade school. They cancel out. In truth, they don't cancel out. There is that 1 there. That 1 is always there. So I don't like how people say, or teachers say, cancels out, because it's still there. And in calculus, you can pull that 1 back out because sometimes it becomes a powerful method we can use to simplify an equation. So that 1 is still there. Don't ever forget that. A number will always have a multiply by 1 there that we can utilize as a tool. So we have that, which equals this 12 divided by 4. So I'm going to erase this right here, this times 1, just for the simplicity of remembering A equals B divided by C. Is that the form I used? I did B equals A divided by C. Let me erase that. B equals A divided by C. All right, so 3 equals 12 divided by 4. Is that true? Let's find out. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 3, we got 1, 2, 3 sets of 4 gives us 12. So yeah, 3 equals 12 divided by 4. That gives us 3 sets of 4, right? So multiplication is just the inverse of division. The division is just the inverse of multiplication. They can go either way, vice versa. It's a powerful tool in simplifying and solving expressions that we end up with in certain situations. Let's take a few examples. Let's say we have 5 times 4 equals 20. What is the inverse of this expression or this equation? We can use the word equation because there is an equal sign. There is equality here, so we can use the word equation and not expression. Usually, an expression does not have an equation sign. So, 12 times 4 is equal to 20. 12 times 4. What? 5 times 4 is equal to 20. What is the inverse? So remember, A equals B times C if B equals A divided by C. So we can take this, it doesn't matter which way, you can take 5 or 4. It doesn't, the same thing with our equation up here. We could have took the 3 and divided the 12 by the 3 instead. It doesn't matter which one you use. We still end up with the same answer. On this one here, we'll go ahead and do both ways on this one just to solidify the point. So on this side, that was loud. Let's divide both sides by 4. So we got 5 times 4 divided by 4 equals 20 divided by 4. 4 divided by 4 is 1. So we have 5 equals 4 divided by 20 divided by 4. What is 20 4 times? What's 20 split into 4? We have 5, 10, 15, 20. So it does, in fact, equal 5. So here's an example of A equals B times C. I got it backwards. A equals B times C if B equals A divided by C. Now, what if we did it the other way? We could have took 5 times 4 divided by 5 equals 20 divided by 5. Always do this. If you do something to one side of the equation, always do it to the other side as well. Keep things equal. If you have an equation, if you have an equality, keep things equal. So now that we talked about the inverse of multiplication, let's touch on division. Division is the inverse of multiplication, but it's much more than that. Division is a powerful tool in mathematics. So the answer to a division problem is your quotient. Your quotient is your answer to a division problem. So say if you have say we have 25 divided by 5, your answer would, or your quotient would be 5. Now, just like with multiplication, you will never see a division problem written like this in algebra and beyond. Division is known to be much more than one number divided by another number. A division problem is a problem of ratios. Ratio. What this means is that division problems are written in rational format. So you have a rational numbers. Notice how we have the word ratio right there. Now, we talked about rational numbers in the first video, talking about sets and whatnot. One of the sets of real numbers was rational numbers. So this number right here, 25 divided by 5, that's a rational number. How do we write it as one? You write it as 25 divided by 5 as a fraction. You write it as a fraction. You will no longer see this dividend symbol or this divisor, I forget what it was called. I think it was called a divisor symbol. You will no longer see this in mathematics, at least as far as I'm aware. I'm not I'm not into the deep into mathematics, but I haven't seen it in calculus. Put it that way. I have seen this though. You will see 25 over 5 as a fraction, which equals 5 as the quotient. Or it really simplifies into 5 because 5, think about it, is still a rational number. Isn't 5 also equal to 5 divided by 1, which is still equal to 5? So therefore 5 is also a rational number too, right? Technically speaking, I think so. It's true. It is a rational number, but it's not thought of one because you don't need to use the properties of rational numbers if a number isn't required to have 1 as its denominator. But that's for another story. Let's finish off the easy stuff first. Then we'll get into all the logic type of thinking things that us math people like to do. One other thing about numbers or about rational numbers. Let's pick two numbers that don't divide into each other. One such number would be 3 divided by 4. 3 divided by 4 does not divide. That is as simplified as that number can get. And you would see this fraction, you would think of this as, oh, that's 3/4. That is literally 1, 2, 3/4 of a pie, right? I'm not an artist. I used to be, not anymore. So this is 3/4, right? You don't need to write this like that. There's another way of writing this. I'm going to show you a type of definition. We have A divided by B. What does A divided by B equals? It's the same of saying A times, here is our inverse of multiplication. 1 over B, or 1 divided by B. A fraction is a whole number divided by the denominator, right? So the whole number divided by the inverse of a number is the same as saying a rational number. So when we had 3 divided by 4, that is the same thing as saying 3 times 1 over 4. This type of thinking will help you so much in algebra because a lot of people, when you get into the calculus and beyond, we tend to forget our basic preliminaries of mathematics. Things like this. People forget that you could pull that 3 from on top of that 4. For example, maybe you're this far, maybe not. Say we have some type of crazy looking equation like say we have 3x divided by 4 divided by 3x. What is this? You wouldn't know what to do with this if you didn't think about this part right here. But check this out. I could just show you this is equal to 3x divided by 12x, and then we can factor everything out. This ends up being 1 over 4. How was I able to do that fast inside of my head? How? Because I know the fundamentals of algebra, the preliminaries. There's a guy I know. He's fixing to go to college for computer science. He has to take calculus. And now we was talking, he was worried about his algebra going into calculus because he hasn't taken algebra in almost 12 years. He quit school and now he's going back to school. And you know what? I told him, like, dude, let me show you what you do. If you're worried about the algebra going into calculus, go buy a cheap algebra book. Like, for example, here's a great one. Ron Lawson's College Algebra. Ron Lawson, or this is Lawson also, Hostetler. Great algebra book. I told the dude, go read the first chapter. Study the first chapter. Get your preliminaries out. I guarantee you, if you can master the preliminaries, you will not have as difficult a time in calculus as you would think you would. Because 90% of algebra, people fail because they don't think about the preliminaries. They forget the rational expressions. They forget the factoring, the expanding. That's the things they forget. The complex fractions, like this thing right here is a complex fraction, and people freak out on that. If you just take your time and go read the beginning, and books like this is like $5 on eBay. Read the first preliminary chapter and watch how much better you are in algebra and calculus. Guarantee. Guarantee. Now that I touched that tangent, let's move on. I kind of lost myself right here. Let's see, where am I at? What am I doing? What am I doing? We talked about the reciprocal of a real number. That's this right here. So we could take 3 over 4, which equals 3 times 1 over 4. Always remember that you can pull the top number off of a fraction and manipulate it in some way that may be required. It's called the reciprocal. This right here is a reciprocal. And just in case you may be still confused, I want to solidify in your mind what exactly a reciprocal is. Here is 3, a beautiful number 3. I like the number 3. Check this out. The number 3 as a reciprocal, don't put the equal sign, almost messed up. As a reciprocal is 1 over 3. The reciprocal of 4 is 1 over 4. The reciprocal, I should write this down too. Reciprocal. Reciprocal is just the inverse of a number. And we will always have to use inverses far into math. Get used to reciprocals because we use them a lot. Since multiplication is related to division by the reciprocal, it follows that the signs or the rules for the signs are the same. That means when you have a division problem, 12 divided by 4, and both numbers are even, then you're positive, or positive, then your reciprocal or your quotient will also be positive. If both your numbers are negative, then your quotient will be positive, just like with multiplication. And if we have one of these numbers being negative, then your quotient will also be negative. And the same thing goes when you have many numbers and one negative. So you can have 1 divided by 1 divided by negative 1 divided by 1 divided by 1 divided by 1, so forth. Your answer will be negative 1. We got one number, then you got one negative number, then you're going to have a negative quotient. But if you had, say you had 2 negative numbers in there, you would have a positive quotient. Remember that. It'll help. It'll help. Count your negative numbers and you'll know what your final product or quotient will be. This does not apply to sums and differences. Only to products and quotients. Remember that. And by extension of products, that includes exponents. And we'll get to that very soon. I think we have another 2 more lessons before we start on exponents. So that was multiplication and division of real numbers. I hope these lessons are helpful, or at the very least entertaining. If I could be any more entertaining than I am, I would gladly entertain that idea. But I hope these lessons are entertaining and helpful to you. If not, let me know in the comments what I can do to better myself. If I made mistakes, I'm a very mistaken person. There's a lot of mistakes I'm making. I don't catch them. Let me know in the comments. Let me know what's going on. You see, if you think there's something I can do to spice my videos up a little bit, let me know in the comments. With that said, see you next time.